So the final sort of, I guess, like content bit before we look at some study tips for today is about statistical analysis. So from year 11, hopefully you guys remember that a random variable is a variable whose possible values are outcomes of a statistical experiment or a random phenomenon. Okay, so essentially random variables allow us to study random processes, essentially by quantifying their outcomes. Okay, so that's a little bit wordy, so we'll have a little bit more of a look at random variables. So random variables are notated using capital letters, and their values are represented by like the corresponding lowercase letter. Okay, so for example, we can define the random variable big X, so capital X, to be the number of heads thrown after tossing a coin 10 times. Okay, so the probability of the random variable X equals little x or lowercase x is the probability of throwing lowercase x number of heads. Okay, so the probability that we throw heads 7 times is the probability of throwing 7 heads. Probability of heads being greater than or equal to 7 is the probability of throwing at least 7 heads. That's really all there is to it. So yeah, like the uppercase is like the actual variable. So let's say uppercase is number of heads equals lowercase, which is like the probability of throwing whatever number of heads. Okay. So your random variables can be discrete or continuous. So this is a fairly simple part of the variables, but a random variable is discrete if its values can be listed or counted. So if you can exactly count every single possible outcome. So for example, the number of heads received after throwing a coin 5 times, you probably wouldn't, but you could like actually count how the values. And then a variable is continuous if its values can take any value along a continuum. So for example, heights of students in a classroom, if you had the equipment to measure it properly, like you could be like measuring down to like tiny little increments. So it can take any value on a continuum. So hopefully in year 11, you learned about discrete probability distributions. Most schools do this at the end of year 11, I think, so hopefully it's fairly familiar to you, or that you haven't probably thought about it in a while. So essentially this is when every single outcome in the sample space can be counted or listed, and you can account for the probability that each outcome will happen. Okay. In year 12, we sort of start to think about continuous random variables and how there can be an infinite possible number of outcomes because they lie in a continuum. Okay. So like I said, if we had the proper equipment, heights of students in a classroom could be 1.82 meters, could be 1.64383 meters, could be 1.7930944 meters, etc. Okay, like you could, if you had the equipment, have infinite number of heights. So because there are infinite outcomes, this sort of makes it hard to estimate probability, and so the probability of getting a specific value is going to be 0 because there's an infinite number of values you could pick. So when we're looking at these, it makes more sense to find probability of an outcome lying within a range of values, okay? So rather than trying to find the exact, 1.792347627, it makes more sense to sort of think about what's the probability that a height of a student is between 1.7 and 1.8. So to do this, you will use probability density functions. A lot of people hate these, but once you get your head around them, they're not too tricky. So essentially, a probability density function, or a PDF, is a curve that helps us to see the relative likelihood of an outcome and allows us to find the probability of a continuous random variable falling within a particular range of values, okay? So we could find between 1.7 and 1.8, we could find the probability between 1.7 and 1.72 if you wanted to. So you can sort of find all different types of PDFs. So the famous probability density function, and one that you actually may have seen before, or you may not have known what it was, is the standard normal distribution. Now, you guys can disregard this. You don't actually have to know how to use this formula, although it will come up again in year 12, but you don't actually have to know how to use it, so don't be stressed out by that. But essentially, this is an example of a probability density function that would allow us to find the probability, this is actually on the bottom are z-scores. Don't worry about z-scores, you do them in year 12, they're fairly straightforward. But the probability that a z-score is between 0 and 1, for example. So with probability density functions, they all have two properties. If your PDF does not have these two properties, then it is not a probability density function. Okay? First property is that every single f of x is greater than or equal to 0. Essentially, this is because probabilities will all lie between 0 and 1. You can't have a probability less than impossible, which is 0, and you can't have a probability greater than certain, which is 1. The other thing to consider with probability density functions is that the area under the entire graph is equal to 1. So if we were to find the area between infinity and negative infinity, f of x, the integral of f of x relative to x will equal 1. Now this does make sense because the probability of all outcomes should be 1, okay? If you've got, even though there is infinite number of outcomes, theoretically, if you added all of them up, it's certain that at least one of them would happen, so the area has to equal to 1. Okay, so the area under a probability density function corresponds to the probability of that random variable lying within the interval. Okay, so the probability that x is between k and h is equal to the integral from k to h of f of x relative to x. Okay, so the probability, let's say that x is less than or equal to our little x, is referred to the cumulative distribution function. Okay, a lot of people get super confused between PDFs and CDFs, so CDF being the cumulative distribution function. But essentially, your CDF can be found by doing x, little x, to negative infinity of fx dx. Okay, fairly straightforward. But yeah, I think a lot of people do sort of, the more, this is one of those topics that the more you do it, the more you may become a little bit confused by it. But important just to understand that your CDF is going to give you a equation, your PDF is going to give you a curve. Okay, and your CDF will have an x as one of your limits. Okay, your upper limit will be an x with the CDF, whereas when we're thinking of the PDF, you won't have x in your limits. Okay, so because probability density functions illustrate relative likelihoods, you can use them to find continuous random variables just by looking for the x value, which gives the highest value or the maximum on the curve. So to finish off that speed run through statistical analysis, we'll have a look at this practice question. So I'll give you guys maybe a minute, have a go looking at this. Remembering this is new content, so if you don't know it just yet, that's all good. We'll have time to go through it together in a minute. Okay, so this again from 2022 HSC, multiple choice question. Consider the following graph of the PDF f of x. What is the value of the mode? First thing to consider with this question, probability density functions means that on here, on our y-axis is probability that something happens, and then this is the outcome on the x-axis. Then we want to think about what is the mode. So if you don't know, like hey diddle diddle, the median's the middle, you add and divide for the mean. The mode is the one that occurs the most, and the range is the difference between. That's something I learned in like year 7, and I don't want to know why, but it's still stuck with me. So mode is going to be the one that occurs the most. So that's going to be which probability is the highest. So therefore, our mode is going to be pi on 4. Okay, so our answer option is going to be C. Important to remember here that your mode, your median, your mean, things like that, they're all going to be the x values, okay? The y value is just the probability it happens, whereas like the mode, the actual outcome that occurs the most, will be an x value because the x values are our outcomes. Okay, so that